Hello, this lesson is on z-scores, which is about standardizing a variable, and it should be a pretty quick lesson. I'm going to show you how to find a z-score, what it means, and what it indicates in relation to other data. So here we go. All right. I like this lesson. This is fun. Zoom in. There we go. All right. So before we get into z-scores, I want to go over a couple things, a little bit of vocabulary so that you're familiar with it later on. A descriptive measure for a population is called a parameter. And a descriptive measure for a sample is called a statistic. So these words are referring to a value or a number that describes a population, in the case that it's a parameter, and a sample in the case that it's a statistic. So a parameter can be mean, median, mode, standard deviation for the population. And a statistics can be mean, median, mode, standard deviation for a sample. And if you remember way back from the beginning of my videos, population and sample, population, whenever you see that word all, like all people or all basketball players or all test scores, all means population. And then a sample means that they've taken a small portion of the population to gather data on. So I'm summarizing here in this table, a descriptive measure for a population is called a parameter, which we just talked about. And then the symbol for population mean, which is a very popular parameter for population, is called mu, and it looks like this. Mu. It's like a Greek letter. And the symbol for population standard deviation is this little sigma. And then if we're talking about samples, the descriptive measure is called a statistic. The symbol for sample mean we've actually seen before. We call it X bar. And the symbol for sample standard deviation we've seen before is S. We could say S. I don't know. You can put something else there if you want. And we use z-scores to compare individual values from different distributions. So I had mentioned earlier it's how we standardize variables. So let's say a college is looking at two students and they really like both the students, but one student took the ACT and one student took the SAT. And if you've ever taken those tests, you know that the scores are vastly different. So maybe on the ACT, the student made a 32, and on the SAT, the other student made a, I don't know, 1500. I have no idea what a good score is on SAT. It's been so long, but you get the point. One is a 32, one is a 1500. How do you even compare those? So we can standardize those variables and put them on a scale that we can look at them and compare them to a population mean. So if we take those scores, we take 32 as an ACT score, and we compare it to the population mean by using z-scores, we can see how far above or below the mean it is. And then if we take the SAT score and compare it to the population mean, we can see how far above or below that score is. And then with that number, the z-score, we can see, oh wow, this student was 3 standard deviations above the mean, or this student was 2 standard deviations below the mean. And that's, you know, when you compare the two, they're vastly different, and you could make your decision that way. So this is the formula for finding a z-score. This is in words. You take the observation that you're looking at minus the population mean, and divide it by the standard deviation. This formula gives us a z-score, which indicates how many standard deviations something is above or below the mean. So when we're subtracting the mean here, if the mean is larger than the value is going to be below the mean. Anyway, you'll see. And then we're dividing by what the standard deviation is. That gives us how many standard deviations the z-score is above or below. You'll see in a second. It's not so confusing. You might see this written as x minus the mean over the standard deviation. So that's just in symbols the same exact thing. And I've talked about this. A z-score gives a numerical value for how many standard deviations an observation is above or below the mean. So if you were given a negative z-score, and the z-score indicates how many standard deviations a value is above or below, a negative score would indicate what? A value, I'll say observation value below the mean. Which means that a positive z-score would be an observation value above the mean. So it gives you a relative standing of the value as compared to the mean. Is it above, below, or the last option, if you get a z-score of 0, then that means that you have an observation value equal to the mean. Whoops. There we go. So there's kind of a introduction to z-scores. We're going to do an example to show you the application of it. And this one's kind of fun. I like this one. Suppose you buy a new car whose advertised gas mileage is 30 miles per gallon. After driving the car for several months, you notice you get a mileage of 27 miles per gallon. You call the manufacturer to inquire about this, and they inform you that the standard deviation gas mileage for all cars of the model you bought is 2 miles per gallon. So this indicates the population. We're comparing your car to all cars. So these are parameters. 30 miles per gallon and 2 miles per gallon are considered parameters. So find the z-score for the gas mileage of your car, assuming the claim is correct. And in this case, your car is 27 miles per gallon. So if you need to pause it and figure that out, you can. Just to remind you, the formula is x minus the mean over the standard deviation. Pause it, try it, come back. You should get 27 is your car minus the population mean over this population standard deviation. It is below the mean, so we end up with negative. I'm going to write that in decimal form. Which means that, so what is this number? I found negative 1.5. What is that number? Is it miles per gallon? Is it standard deviation? What does it mean? Negative 1.5 means that your car is 1.5 standard deviations above or below? Below the mean of 30 miles per gallon. And the question is, according to this z-score, does it appear that your car is getting unusually lower gas mileage? And here, for something to be unusually low or unusually high, it would be more than 3 standard deviations above or below the mean. So you could put a side note here, 3 standard deviations above or below the mean. That would be unusual. So in this case, your car is only 1.5 standard deviations below the mean. While it is below the mean, you are getting less gas mileage. It is not unusually low. I would guess that if it were like negative 3.5, maybe there's something wrong with the car, you'd take it back in and they would probably get it fixed. So that's z-scores. That's how you compare variables. That's how you standardize variables. If you have any questions, please let me know and I would be happy to help.